As I look at this integral, because I have this radical with something under it, I think of possibly a u substitution. And if I let this 1 plus x squared be my u, my du would involve a term with an x in it. And I have a term with an x in it, but I've actually got a couple more x's multiplied up here as well. But that may end up working out for my substitution. So I'm going to start there and see. So I'm going to let u be 1 plus x squared, which would mean du is going to be 2x dx, and so 1/2 du would be x dx. So as I go to do this substitution, I'm going to split this up, and I'm going to split it up into an x squared and then an x. That way I'd have my x dx that I need for my du, but I'm going to need to substitute something in terms of u for this x squared. Well, here's my connection between x and u. I could solve this for x squared, and then x squared would be u minus 1. So I can replace this x squared with u minus 1. I can replace the x dx with 1/2 du, so we'll put the 1/2 out here in front. And then I have the square root of u here. So that worked actually quite nicely to do my substitution. Now I can go ahead and split this up and take this to each piece in the numerator. So I'd have 1/2 times the integral. So this is u divided by square root of u, which is like u to the 1/2. So I would subtract exponents, and that would make a u to the 1/2, and then minus, and expressing this one as an exponent and not as a fraction, that would be u to the negative 1/2 then for this piece, and then my du. So I now have it in terms of just functions with powers. This would make it easy then to integrate. So I've got 1/2, and then this would be u to the 1 higher power, but I need the reciprocal of the power. And here then I would have minus, I would need 1 higher power, which make that a 1/2, and then I need the reciprocal of the power, so that would put a 2 on there, and then plus a constant. So as I look at this, I can actually get rid of this 1/2 because I could cancel it here and here. Now let's go ahead and resubstitute, and so it looks like I have 1/3, and my u was 1 plus x squared, and that's to the 3/2, minus my 1 plus x squared, this time to the 1/2, and then plus a constant. Now in looking at this, we could leave it like this, but we could also factor out a 1 plus x squared to the 1/2, and if I did that, put that out in front, 1 plus x squared to the 1/2, and then that would leave me a 1/3, and this will be 1 plus x squared, and then this would be minus 1, and we still have plus our constant. So I could simplify this further because I could actually combine terms here and then maybe rewrite this back as a radical, just because that's what I started with. And it's not incorrect to leave this. I'm just showing you, so maybe you looked at some solution to this and it's written differently, and just showing you how they might do that. So I'm going to go a little sideways here to fit this on. So I'm going to write this back in radical form, which would be like this. If I distribute this through, I'd have a 1/3, and then I have minus a 1 there. So I could express this as a 1/3 x squared minus 2/3 and plus a constant. Actually, one last way we could write this is probably how you'd see it as a solution, is we could take this 1/3 out. So we could put the 1/3 out in front, square root of 1 plus x squared, and then that would leave x squared minus 2 plus a constant. Sorry for making you tip your head.